Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 5 video on the chapter of linear equations where I will solve the test paper 8, which are mostly multiple choice questions based on the chapter of linear equations, and some questions are based on the chapter of algebraic expressions, that is operations on algebraic expressions. So if you have not watched the previous 4-part videos on the chapter of linear equations, I strongly request and suggest that you watch those videos as well to maintain the continuity of your study on the chapter of linear equations. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the test paper 8 on the chapter of linear equations and operations on algebraic expressions. Okay, so I have the test paper 8 questions on the left hand side. I hope it has been I have zoomed in quite a bit so that the questions are properly readable. On the right hand side, I will solve the problems. So while I am solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. So as always, try to solve the state test paper yourself. Ideally, there are how many questions are there? There are total 17 questions. So ideally, you should be able to solve these questions in an hour, or better if in 45 minutes. Okay. Okay, so let's start solving the problems. Now I am again working in Mac, which has a very bad configuration. I don't know how it will go because this is a very slow machine. Let me see how it goes. Okay, so section A, problem number 1. I'm already having a very bad experience. The writing is very slow. Anyway, subtract. It is asking to subtract one expression from another one. So we have to subtract from the algebraic expression is given 2s square minus 3b square minus 3b square minus 4c square minus 5. From this expression, we have to subtract 4a square plus 5b square minus 6c square plus 8. So we know that if you recall subtraction and addition of algebraic expressions, you just, if there are any expression inside the bracket, and if in front of the bracket there is a negative sign, then you will have to change the sign of all the terms inside the all the terms of the algebraic expression inside the bracket. In this example, when we will open the bracket, this bracket, we will have to change all the signs of the terms inside the bracket. This bracket will open as it is because there is no negative sign in front of it. So we can the first bracket open as it is without any change. So we get 2a square minus 3b square minus 4c square minus 5. But when we open the second bracket, there is a negative sign in front of it. So all the terms inside of the expression inside the bracket will change their sign. So 4a square will become minus 4a square. Plus 5b square will become minus 5b square. Minus 6c square will become plus 6c square, and plus 8 will become minus 8. So now the next task is to group all the like terms and add them. So let's group all the like terms. Let's group the terms, like terms of the terms a square. So we have 2a square and minus 4a square. Let's group the terms b square, that is we have minus 3b square minus 3b square, and we have minus 5b square. Let's group the terms c square. So we have minus 4c square plus 6c square, and let's group the constant terms, and we have minus 5 minus 8. Now if you add up all the like terms, we get minus 2a square minus 8 b square, we have plus 2c square, and we have minus 13. Okay, so this was a subjective question. This was not an MCQ. So this is the final result of the subtraction. So the result is minus 2a square minus 8b square plus 2c square and minus 13. And I can already see that my handwriting is very jittery because the machine is working very slow. I really don't know how many questions I can solve because I've already started to have a very bad experience. Because I switched to Mac because I like this software. I use Notability for the discussion part on the right hand side. Anyway, let's do problem number 2. Find each of the following products. So we have to find the products of algebraic expressions. The first one is 4a plus 5b multiplied by 5a minus 6b. So this is a product of two binomials. This is a binomial and this is a binomial. And you know that when you do product of two binomials, you have to apply the distributive law of multiplication over addition or subtraction twice. So I can consider, let's say I will consider this expression as x and this expression as y minus z, just for the sake of clarity of just for the sake of calculation, easiness of calculation. But while solving this problem in your board, in your exam, definitely you will not write this x, y, z. And the distributive law of multiplication over subtraction is that if you have x multiplied by y minus z, this is equal to x, y, that is x multiplied by y minus x multiplied by z. And my handwriting experience is just horrible. I don't know whether I can complete this or not. Anyway, so this is xy minus xz. So if we apply the distributive law of multiplication over subtraction, this becomes 4a plus 5b multiplied by 5a and then minus 4a plus 5b multiplied by 6b. Now as you can see, we again see we have a product of monomial and binomial, and again we have to apply the distributive law of multiplication over addition. So this becomes 4a multiplied by 5a plus 5b multiplied by 5a minus 4a multiplied by 6b minus 5b multiplied by 6b. Okay. Now we have to do all the multiplication of the monomials, and we get 4a multiplied by 5a is 20a square. 5b multiplied by 5a is 25ab. 4a multiplied by 6b is 24ab. And 5b minus 6b is 30b square. Now we add up the like terms. The like terms are 25ab and minus 24ab, and so it becomes 20a square plus ab minus 30b square. So this is the result of the product of the given two binomials. Okay, let's do the part 2 of problem number 2. It is a product of a trinomial, that is a polynomial with a binomial. The polynomial is minus 6x square minus x plus 8 multiplied by the binomial is x square minus 3. How do you do the product of a binomial and a polynomial? You find the product of the binomial with all the terms of the polynomial and then add them up. So the terms of the polynomial are 6x square minus x and plus 8. So you will multiply all these terms with the binomial x square minus 3. So this will become 6x square, multiplying the first term with the binomial and then multiplying the second term with the binomial. Actually, the right way of doing is plus minus x, because the second term is minus x multiplied by the binomial x square minus 3 and plus 8 multiplied by the binomial. Okay, now I am writing very slowly, because if I try to write fast, then my handwriting is become it is becoming jittery, because the machine is working very slow. Very pathetic experience. Anyway, so now we have to do product of monomial and binomials. So we get 6 x to the power 4 minus 18 x square. Then we have minus x cube, and then we have plus 3x, and then we have plus 8x square, and then we have minus 24. Now I will not describe in very details how I am doing the product of two algebraic expressions. I hope you have already a good idea. You have already completed the chapter of operations on algebraic expressions. If you have not, I can suggest you to watch my videos in this same playlist. Okay. So now we have this. Now we have to collect the like terms and add them up. So we have 6x4, x to the power 4 is the only term on its own. Then we will collect the term of x square, that is minus 18x square plus 8x square. And then before this, always when you write a polynomial, always try to write the terms in descending order of the degree of the terms. So the first, that is write the term with the highest degree. What is degree? Degree of a term is the sum of the powers of all its variables. So the highest degree of the term is x to the power 4, and then will come x to the x cube. So we will have minus x cube, and then we will have all the x square terms. So after the x square terms, we will write the x terms. Okay. So what are the x terms? X terms is only 3x. And then after the x terms, we write the constants, that is minus 24. Now, if we add up the like terms, we get the final result as 6x to the power 4 minus x cube, and then minus 10 x square and then plus 3x and then minus 24. This is the final product. This video will be very long. I can understand that, because I am writing, I am forced to write very slowly, because if I try to write fast, my handwriting will become very weird. Okay, so let's do problem number 3. Divide. So we have a division of two polynomials. We have to perform the dividend is 5a cube minus 4a square plus 3a plus 18. Okay, and the divisor is a square minus 2a plus 3. Now in this kind of division problem, if you can factorize both the dividend and the divisor, you always do that first. It is highly recommended to factorize the dividend and divisor if it can at all be factorized. If you cannot, then you can proceed with the long division method. But if you can factorize, then probably a lot of factors will get cancelled out from the dividend and divisor, and it will be easier to solve. But in this problem, I do not think I can factorize the divisor a square minus 2a plus 3. I do not think I can factorize it, because I won't be able to find the two numbers a and b whose sum is minus 2 and whose product is 3. So this cannot be factorized. So I have to do, but can I factorize the dividend? Can I factorize the dividend? I don't think so. So anyway, just proceed with the long division method. So how do we do long division method? In doing the division of two polynomials, we first figure out what will be the first term of the quotient. The first term of quotient will be equal to the first term of the dividend divided by the first term of the divisor. This is equal to 5a. This is 5a will be the first term of the quotient. Now we proceed with the division. The divisor is a square minus twice a plus 3, and the dividend is 5a cube minus 4a square plus 3a minus 18. And the first term of the question we got 5a. Okay. So we have to multiply the first term with the divisor and subtract the product from the dividend. So what is the product of 5a? So we have to what is the product of 5a, that is the first term of the question, with the divisor a square minus twice a plus 3. This is equal to, so this is a kind of side calculation I am doing. 5a cube minus 10a square minus 10a square and then plus 15a. So I have to subtract this from the dividend. So 5a cube minus 10a square plus 50 plus 15a. This need to be subtracted from the dividend. So the sign will changes when I am subtracting. Minus plus, that is the sign of the terms of the product, minus. So 5a cube minus 5a cube cancels out and we have minus 4a square plus 10a square, which becomes 6a square, and then we have 3a minus 15a, which becomes minus 12a, and then we see there is a single term left in the dividend, which is minus 18. We will bring that down and add with the remainder, and we have the new dividend becomes 6a square minus 12a minus 18. So what will be the next term of the question? It will be the first term of the dividend, that is the current dividend, that is 6a square divided by the first term of the divisor, that is a square. This is equal to 6. So the next term of the question will be 6, that is plus 6. And again we will find the product of 6 with the divisor and subtract the product from the dividend, from the current dividend. So the product of 6 and the divisor is 6a square minus 12a plus 18 plus 18. Why it is plus 8? Okay. Okay. Oh, this was plus 18. Sorry. This the in the dividend this was plus 18. So plus. So this will be plus. Okay. So now we can see that if we do the subtraction, this is minus, this is positive, and this is minus. So all the terms are getting cancel out, and we see there is no remainder. So we are getting a perfect division. So the answer question, so we have to divide this. So the answer is, or the answer of the question is equal to 5a plus 6. This is the question of the division, or you can say this is the answer or the result of the given division. Okay. Let's do problem number 4. It is given x minus 1 by x is equal to 4. Then find the value of, we have to find part 1, we have to find the value of x square plus 1 by x square, and part 2 we have to find the value of x to the power 4 plus 1 by x to the power 4. Now in this kind of problem, when you are given this kind of equation, you are having some x minus 1 by x, that is some difference or sum of two terms where the terms are reciprocal of each other. As you can see, x and 1 by x, they are reciprocal of each other, and if the sum and difference are value is given, you always first try to square that and see what you get. So from here we get, squaring both sides, we get x minus 1 by x. So I am squaring both sides of the equation, that is x minus 1 by x is equal to 4. I get is equal to 4 square. So this implies if I apply the a minus b whole square on the LHS, I get x square that is a square plus b square, that is 1 by x square, and minus twice ab, that is minus 2, a is x and b is 1 by x, is equal to 16. Now this implies x square plus 1 by x square, we get minus 2 because x and 1 by x cancels out, is equal to 16. So this implies x square plus 1 by x square is equal to 16 plus 2, that is 18. So the first part is done, that is x square plus 1 by x square is 18. Okay. Okay, so we got this value. Now we have to find x to the power 4 plus 1 by x to the power 4. Now how can we get x to the power 4? X to the power 4 we can get by squaring x square. So from this equation, if you square both sides, we get x square plus 1 by x square whole square is equal to 18 square, is equal to 18 square. Okay. Now if you apply the a plus b whole square formula on the LHS, you get a square, square of x square will be x to the power 4, and square of 1 by x square will be 1 by x to the power 4, and we have plus 2ab where a is x square and b is 1 by x square. And what is 18 square? 18 square, okay. So I have to quickly calculate what is 18 square. 144, 18, 324. So this is 324. Okay. So this implies x to the power 4 plus 1 by x to the power 4 plus 2 is equal to 324. This implies x to the power 4 plus 1 by x to the power 4 is equal to 324 minus 2, which is equal to 322. Okay, let's do problem number 5. We have to evaluate the given expression 83 square minus 17 square. So to evaluate this kind of expressions where all the expressions are constants, the terms are constants, and it is in the form a square minus b square, we know that we can apply the identity a square minus b square is equal to a minus b multiplied by a plus b. So this becomes 83 minus 17 is 63, no, 66, and 83 plus 17 is 100. So this is equal to 6600. Okay, let's do problem number 6. Problem number 6 is about factorization. The part 1 is the given polynomial is x cube minus 3x square plus x minus 3. Now, since this is the power is the polynomial is having a degree of 3, we cannot apply it's power of 3. We first of all we see that there is no common term, there is no common factor of all the terms. The terms of this expression are not having any common factor. Then we will try out if it is forming any a plus b whole square or a minus b whole square form. We see that it is not. Also, we will then try to see if it is in the form of a square minus b square. It is not in that form. So the last option is we have to group terms so that all the groups will have some common factor, and we can clearly see we can do that. We can create group from the first two terms and create another group from the last two terms. And from the first group, we can take common factor as x, and we get x multiplied by x square minus 3 x square. The common factor will be x square, not x. The common factor, I hope I made a video about the common factors, irreducible factors, and irreducible form of an algebraic expression in the chapter from the chapter factorization. It is that is a very important video. You can if you please take out some time and watch that video, and you will be it will be very clear to you how to find the common factor of all the terms of an algebraic expression, because figuring out the common factors is very important and a very crucial step in factorization of a given polynomial. So for the first group, the common factor will be x square, and then we get if we factor out x square from the first two terms, that is from the first group, we get x square multiplied by x minus 3, and then the second group, let the second group be as it is. Now, okay, so now we can see that the first group is having a common factor. Both the groups are having a common factor of x minus 3, because x minus 3 you can always consider it as x minus 3 multiplied by 1. So now if we factor out the common factor x minus 3 from the two groups, we get x minus 3 multiplied by x square plus 1. So this is the factorization of the given polynomial or given expression. Okay, let's do part 2. It is 63 x square y square minus 7. Excuse me friends, I will just put my laptop is almost discharged. Let me put it in power. Okay. Okay. So this now we can see that this is a binomial. It has two terms, and both the terms is having a common factor of 7. So we can factor out 7 from both the terms, and we get 9 x square y square minus 1. And the factorization, as you can see, is not yet complete, because this expression 9x square y square minus 1 is in the form of a square minus b square, because we can write it as 3xy square of 3xy, and 1 can be written as 1 square. So now we have to factorize this part again using the formula a square minus b square is equal to a square a plus b into a minus b, and hence the final factorization will become 7 into 3xy plus 1 multiplied by 3xy minus 1. So this is the final factorization. Okay, let's do part 3. Part 3 is a trinomial 1 minus 6x plus 9x square. Now, whenever you are given a trinomial, always first write it in the order such that all the terms are arranged in descending order of their degree. So, the highest power of the variable will come first. So, 9x square and then minus 6x plus 1. Okay, now we have to find, so this is a trinomial, this is a quadratic trinomial. Why? Because it has 3 terms, that is why it is known as trinomial, and quadratic means a polynomial of degree 2 is known as quadratic. So we have to find, as you know, to factorize this kind of quadratic trinomial, we try to find numbers a and b such that a plus b will be equal to the coefficient of x, that is minus 6, and a multiplied by b will be the product of the constant terms and the coefficient of x squared, that is 9. We have to find a and b such that a plus b is equal to minus 6 and ab equals to 9. We can clearly see that we can say a is equal to minus 3 and b is equal to minus 3, because their sum will be minus 6 and the product will be 9. So now once we have found a and b, we will rewrite this expression as 9x square, and instead of the minus 6, we will write a plus b, that is minus 3 plus a plus b, that is a is also minus 3 and b is also minus 3. So we can write it as minus 3 x plus 1. Now this becomes 9x square minus 3x minus 3x plus 1. Now you take you form a group of the first 2 terms and another group from the last 2 terms, and you take and you find out there must be a common factor in the 2 terms. So from the first group, I can take common factor as 3x. In the first group, both the terms of the first group is having a common factor of 3x. So if I take out the common factor, it will be 3x multiplied by 3x minus 1, and the second group I can write it as minus 3x plus 1, Now, as of now, I do not see any common factor in the two groups. That is, in this group I can see a factor of 3x minus 1, but in this group is a minus 3x plus 1. But I know that minus 3x, the second group can be rewritten as, if I take minus common from the second group, that is minus common from both the terms of the second group, I can say this will be equal to minus 3x minus 1. I have taken minus 1 common, minus 1 as common factor from both the terms of the second group. Now I can see there is a common factor of 3x minus 1 from both the groups, and the final factorization will be 3x minus 1 multiplied by 3x minus 1, which is essentially square of 3x minus 1 whole square. Now the question is that since the factorization has turned out to be a square of something, then in the first place from the given polynomial, that is expression, we should have identified that it is in the form of a plus b whole square or a minus b whole square, because as you can see, the expression given was I was not aware of that fact. So the expression was 1 minus 6x plus 9x square. Now whenever you are given a quadratic trinomial, you always try first to see if it is having the form a square plus b square plus twice ab, or a square plus b square minus twice ab. Then you can express it as a square of a difference or sum of two terms. Now I can clearly see that this can be written as 9x square. This is 1 square plus 9x square can be written as 3x square of 3x. So I already got the a square plus b square form. Now I need to check whether I can have minus twice minus minus 2ab, that is a is over here 1 and b is 3x, and I indeed see that it is minus 6x which is in the given polynomial. So from here I can say that this is equal to 1 minus 3x whole square. Now whether you write it as 1 minus 3x whole square or 3x minus 1 whole square, it will be the same thing. It does not matter. Both the forms are correct. They are the same thing. Okay. Let's do part 4. The expression given is 7x square minus 19x minus 6. So clearly I cannot see any form a square plus b square plus 2ab or minus 2ab, because the 7x square cannot be, 7 is not a perfect square, and also the constant term, it is a minus 6, it is not a positive. So the form has to be either a square plus b square plus twice ab, or it has to be a square plus b square minus twice ab. Then only we can express it as a square of express it as a whole square. So definitely we have to do the factorization by finding this is a quadratic trinomial. We have to find a and b, the two numbers a and b, such that a plus b will be equal to the coefficient of x, that is minus 19, and a into b will be the product of the constant terms, that is minus 6, and the coefficient of x square, which is equal to minus 42. So we have to find a and b such that the constant values a and b such that a plus b is minus 19 and ab is equal to minus 42. Okay. Now you have to factorize minus 42 and see, and have to figure it out what can a and b be. So minus 42. Now minus, if we consider minus 6 and 7, their addition is plus 1. It is not equal to minus 19. So a and b cannot be minus 6 or 7. What can be other factorization of, what can be two other factors of minus 42? It can be minus 3 multiplied by 14. It can be minus 3 and 14, and it will not work. The factors minus 3, 14 will not work, or even if you consider 3 and minus 14, it will not work because the addition will never be minus 19. Now, if we break down 14, so let's say this is minus 3 multiplied by 7 multiplied by 2. Now, minus 3 into 7, I can consider is minus 21 and into 2. Now, I can see that minus 21 and 2 can be considered as their addition is minus 19 and also their product is minus 42. So, you can consider A as minus 21 and B as 2. So, whenever you have found A and B in factorization of a quadratic trinomial, when you have found A and B, then you can directly write the factorization form of the given expression, and it will be x plus A multiplied by x plus B. So you can consider anything as A, any value as A and any value as B. Essentially it will be x minus 21 multiplied by x plus 2. So this will be the factorization of the given expression. Okay. Let's do problem number 7. So this is a we have to solve x. This is from the chapter linear equations. We have to solve the equation given is 2x plus 7 divided by 3x plus 5 is equal to 15 by 17, and we know that we have to solve this by cross multiplication. The LHS is a rational term where both the numerator and the denominator is having the variable x. So we have to apply cross multiplication. Applying cross multiplication, we get 17 multiplied by 2x plus 7 is equal to 15 multiplied by 3x plus 5. Now, if you do the products on both the sides and open up the brackets, we get 17 into 2x is 34x, 17 into 7 is 119, equals to 15 into 3x is 45x, and 15 into 5 is 75. Now, I will bring all the variable terms, that is all the x terms, to the left hand side and all the constant terms to the right hand side by transposition of terms, and I get 34x minus 45x is equal to 75 minus 119. Now, after simplifying the LHS and RHS, we get 34x minus 45x is minus 11x is equal to 75 minus 119 is how much? 4, and it is 4 minus 44. So this implies x is equal to minus 44 divided by minus 11, which is 4. So the solution of the given equation, the solution or root of the given equation is 4, or you can say the value of x which satisfies the given equation is 4. Okay. Let's do problem number 8. Okay, so this is a what problem? This is a problem which is an application of linear equations, and this is a standard problems related to ages. Okay, So 5 years ago, a man was 7 times as old as his son. After 5 years, he will be thrice as old as his son. Find their present ages. Okay. So as usual, we will assume the age of the son, present age of the son. So let present age of son be x years. So this implies it is given that the man was 5 years ago, the man was 7 times as old as his son. Okay. So uh, after 5 years, it is given that 5 years ago a man was 7 times as old as his son. Okay, 5 years ago, and after 5 years, that is in the presently, after 5 years, he will be thrice as old as his son, which basically means that the present age of the man is thrice as old as the present age of son. So this implies present. So it is very crucial that you understand the statement of the given problem. It is very super important. If you misunderstand the problem, you will create a wrong equation, and hence you will get wrong answer. Always try to read the problems 2 or 3 times and be clear what it is given, what information it has given, and what it is asking. So 5 years ago, it is saying that 5 years ago a man was 7 times as old as his son. After 5 years means the presently he will be thrice as old as his son. So present age of man is equal to 3x. That is thrice the old as the son. So 3x. Okay. So we have assumed the present age of the sun to be 3x. We have assumed present age of the sun to be x years, and from the given information in the problem, we know that the present age of the man will be 3 times the age of the sun, so it is 3x. Now let's try to see what will be the ages 5 years ago. So this implies 5 years ago, 5 years ago, age of sun will be equal to x minus 5 years. X minus 5 years. Similarly, 5 years ago, age of man will be the present age of the man. We know it is 3x. So 5 years ago, it will be his age, the age of the man will be 3x minus 5 years. Now it is given that 5 years ago, a man was 7 times as old as his son. So we can say that 3x minus 5, which is the age of the man 5 years ago, will be 7 times the age of the son 5 years ago, which is x minus 5. So this is the equation we created, we formed, which we need to solve. Solving this, we will get x, which will be the present age of the sun. Okay. So now we have to solve this. So we get 3x minus 5 is equal to 7x minus 35. This implies 3x minus 7x is equal to minus 35 plus 5. This implies minus 4x is equal to minus 30. What? No. X has to be some integer. Let me see if I am doing anything wrong. 3x minus 5 is equal to 7 into x minus 5. Okay. So 3x minus 5 is equal to 7x minus 35. Okay. And 3x minus 7x is equal to minus 35 plus 5. So minus 4x is equal to minus 30. How can this be? Uh, 5 years ago, a man was 7 times as old as his son. The present age of the son we have considered to be x. 5 years ago, the age of the son will be x minus 5. So if you have assumed the present age of son to be x years, then definitely the present age of the man will be 3x. Oh, sorry. I'm wrong. After 5 years means after 5 years from the present time. 5 years from the present time. After 5 years, he will be thrice as old as the son. So we have assumed the present age of son to be x years. So okay, I have to do it again. So this is exactly what I was saying, that it is super important that you understand the given problem very well. If required, read it 2, 3 or 4 times. I understood that I misunderstood the problem only when I came to an equation which will not give the value of x as an integer, and x has to be an integer anyway. So my bad. Okay. So it is saying that after 5 years he will be thrice as old as his son, which means that after 5 years means 5 years from now. 5 years from now. Okay. Let present age of son be x years. Okay. So we can say that this implies after 5 years after 5 years age of son is equal to x plus 5. After 5 years means 5 years from now. So x plus 5 years. And it is given that after 5 years, the man will be thrice as old as his son. So this implies that after 5 years, age of man will be equal to 3 times the age of the son after 5 years. That is 3 into x plus 5. Okay. Now it is also given that 5 years ago, a man was 7 times as old as his son. Now 3 into the, so what we have got, we got the present age of the son is x years, and the after 5 years from now, the age of the man is 3 into x plus 5, which is equal to let's say 3x plus 15. This is the age of the man after 5 years. So this will imply that present age of man will be equal to 3x plus 15 minus 5, because 3x plus 15 was the age of the man after 5 years. So the present age of the man will be 3x plus 15 minus 5. This is equal to 3x plus 10. So we got the present age of the son and the man. The son we have assumed the present age to be x, and we have found that the present age of the man to be 3x plus 10. Now we will apply the information that 5 years ago a man was 7 times as old as his son. So age 5 years ago, 5 years ago, age of man will be equal to 3x plus 10 minus 5, which is equal to 3x plus 5. And so this implies that 3x plus 5, which is the age of the man 5 years ago, is given to be 7 times the age of the son 5 years ago. So this will be 7 multiplied by what is the age of the sun 5 years ago? It is x minus 5. So this is the equation we got, and we have to solve for x, where x we have assumed to be the present age of the sun. So this implies 3x plus 5 is equal to 7x minus 35. So this implies 3x minus 7x is equal to minus 35 minus 5. So this implies minus 4x is equal to minus 40. This implies x is equal to minus 40 by minus 4, which is equal to 10. So the present age of sun is 10. So this implies present age of sun is equal to 10. Present age of man we know to be equal to 3x plus 10. We already know that the present age of the man in terms of x will be 3x plus 10. So this is 3 into 10 plus 10, which is equal to 40 years. 10 years. Okay. Okay, let's do section B. These are multiple choice questions. Question number 9. So it is given what will be AB minus A minus B plus 1. So basically it is asking to simplify this term. Simplify means possibly if we can factorize this expression, we should factorize it, because as you can see in all the choices we are having product of some factors. So we can you can clearly see that we can form groups from the first two terms and the last two terms. And from the first term, we can take A as the common factor, and we get A multiplied by B minus 1. And the second group is minus B plus 1. Now the second group can be rewritten or re-expressed as by taking minus 1 common from both the terms of the second group. This is the second group. The second group is minus B plus 1. So if you take minus 1 as common factor from both the terms of the second group, we get minus of B minus 1. Now you can see we are having a common factor of B minus 1 from both the groups, and if we take out that as a factor, we get B minus 1 multiplied by A minus 1. So this is the factorization of the given expression, and hence the correct choice is C. C is the correct choice. C is the correct choice. Okay. Question number 10. This is also we have to factorize. The given expression is 3 plus 23x minus 8x square and clearly we see it is of the form, it is a quadratic trinomial. Definitely we are not having the form a square plus b square, because clearly minus 8x square cannot be of the form a square, because a square and b square they both must be positive. So we have to factorize this expression, we have to find a and b such that a plus b will be equal to the coefficient of x, that is 23, and a multiplied by b will be equal to the product of the constant term multiplied by the product of the coefficient of x square, that is minus 8. This is equal to minus 24. So AB is equal to minus 24 and A plus B equals to 23. So clearly we can see that A can be considered as minus 24 and A can be considered as 24 and B can be considered as minus 1. So their sum will be 23 and the product will be minus 24. So once we have found A and B, we can clearly say that the factorization will be x plus 24. The factorization is actually x plus A multiplied by x plus B, and we know that A is 24 and B is minus 1, but you can also consider A as minus B and B as 24. It will give the same result. So x plus 24 multiplied by x minus 1 should be the factorization, and hence the correct choice for problem number 10 will be none of this. We are not having why we are not having our answer as the choice. Minus x square. Let me see if I did it correctly or not. It is important that you find the values of A and B correctly. So the expression was 3 plus 23x minus 8x square. Okay. So A plus B must be equal to 23 and AB must be equal to minus 24. Okay. So we can clearly see that we can take A as 24 and B as minus 1. Fine. B as 1. Okay. So I think the answer will be none of this, because no other choices are matching with this. And this is, I guess, in my opinion, this is the correct result, correct factorization. So for problem number 10, the choice is D. The choice is D. Okay. Problem number 11 is also a problem on factorization. We have to factorize 7x square 7x square minus 19x minus 6. So clearly we have to find A and B. We have to find the numbers A and B such that A plus B is equal to the coefficient of x, that is minus 19, and A multiplied by B will be equal to the constant term multiplied by the coefficient of x square, that is 7, which is equal to minus 42. And I think we have already done this problem earlier. So problem number 6 part 4, we have already done this. Okay, let's do it again. So what can be the values of A and B such that A plus B is equal to minus 19 and AB equals to minus 42. So you have to create factors of minus 2 factors of minus 42 and check it out whether their sum is minus 19 or not. So we were having clearly minus 42 can be written as minus 21 multiplied by 2. So we can say A as minus 21 and B as 2. So the factorization clearly will be x minus 21 multiplied by x plus 2. This is the factorization, and hence the correct choice should be x minus 21. What is happening? Is there any other combination? Is there any other combination? Is there any other value of A and B other than minus 21 and 2 that their sum will be minus 19 and their product will be minus 42? uh, because x minus 21 product of x minus 21 and x plus 2, this factorization is not given in as a choice in the given problem. X plus 2 multiplied by sorry, my bad. So whenever sorry whenever you have I always make this mistake again and again. So whenever you have a quadratic trinomial of the form p x square plus qx plus r, then definitely you have to find the constants a and b such that a plus b is equal to q and a multiplied by b is equal to pr. Now, once you have found a and b, the factorization will not be equal to x plus a multiplied by x plus b, which is where I am doing the mistake again and again. The factorization, this is not equal to this. Once you have found a and b such that a plus b is equal to q and ab equals to pr, you have to find a and b. To do the factorization of px square plus qx plus r, you have to find the values of a and b such that a plus b is equal to q and ab is equal to pr. But once you have found a and b, you cannot say that the factorization will be x plus a into x plus b. No, that is wrong. The fact you have to proceed. You have to first express. I'm directly solving this problem. Here we know that a is equal to we have considered a as minus 21 and b as 2. Okay, you have to proceed with the given expression, only that you will express the coefficient of x, that is minus 19, as a plus b. That is, you will write minus 21 plus 2 into x, and we have minus 6, and then you will further simplify 7x square minus 21x plus 2x minus 6, and then you will form groups. The first two terms will make the first group, and the last two terms will make the second group. And I can see that from the first group I am having a common factor of 7x, and it becomes 7x multiplied by x minus 3. And from the second group also I am having a common factor of 2, so it becomes 2 multiplied by x minus 3. Now I see that x minus 3 is a common factor in the two groups, and hence I will factor that out, and the final factorization becomes x minus 3 multiplied by 7x plus 2. So the correct choice will be A. A is the correct choice. Now let me see. In the previous problem I said that the answer is D, none of this. No. In solving the previous problem, I also did the same mistake. So we have found A and B as we considered A as 24 and B as minus 21. Okay. Now we have to proceed in rewriting. So I am doing the problem number 10 below again. So the expression was 3 plus 23x. Let's write the expression in the proper form, that is in the descending order of degree of the terms, minus 8x square plus 23x plus 3. So this was the expression, and we have found A and B to be 24 and minus 1. So what will I do is, I will write the expression again, but I will express the coefficient of x as a plus b, that is 24 minus 1, and I have x plus 3. So after further simplifying, we get minus 8x square plus 24x minus x plus 3. So now we will form groups. We will form groups, two groups. The first two terms will make the first group and the second two terms will make the second group. From the first group we can see that we can take 8x as common factor. So 8x, if you take 8x as common factor, we get x 8x multiplied by minus x plus 3, and the second group can be written as minus negative of x minus 3. Now we see the second group can be written as, it was minus x plus 3, it can be written as 3 minus x. Now we can see that minus x plus 3 and 3 minus x, they are basically the same thing. We are having a common factor of 3 minus x in both the groups, and we will factor that common factor out, and we get the final factorization becomes 3 minus x multiplied by 8x plus 1. Why plus 1? Because we can always consider 3 minus x, the expression 3 minus x, to be equal to 3 minus x multiplied by 1. So this is the final factorization, and hence the correct answer choice will be choice B. So for question number 10, the correct choice is B. Okay. Let's do problem number 12. This is also a factorization problem. The given polynomial or the expression is again a quadratic trinomial, 12x square plus 60x plus 75. So clearly we do not see any kind of a square plus b square plus twice ab or a square plus b square minus twice ab form, because 75 is not a perfect square, not even 12x square. So we have to, this is of the form p x square plus qx plus r where p is equal to 12, q is equal to 60 and r is equal to 75. So we have to find the constants a and b such that a plus b will be equal to the coefficient of x, that is 60, and a into b will be equal to the constant term multiplied by the coefficient of x square, that is 12. Now please do not immediately multiply 75 and 12. Let's keep it that way. It will help in finding out the value of a and b. Okay. Now how can we create two factors from 75, whatever the value will be, 75 multiplied by 12, how can we create two factors such that their sum will be 60? Now 75 plus 12 is not 60. 75 can be further written as 15 into 5, and we have multiplied by 12. Now okay, 12. Let's create more factors. 15 is 3 into 5, 3 into 5 into 5, and let's say 12 as 4 into 3. Now can we create two factors so that their sum is 60? 30 and can we create 30 and 30? 30 and 30. No, 20 12, 25 and 24, 25 and 20, 9, 36, 36 and no, uh, 9, 20 and 40, 20 and 45. Now, 3. One thing you note that I did not realize, whenever you do factorization of a given expression, if you see that all the terms of the given expression is having a common factor, always factor that out. I can clearly see that 3 is a common factor in all the terms. So I will first of all take out 3 as common factor from all the 3 terms. So I get 3 multiplied by 4x square, and then I have 20x, and then I have 25. Now you see that this expression, this trinomial, possibly can be expressed as a square plus b square plus twice ab, because 4x square can be expressed as square of 2x, 25 is 5x square, and we just need, since the term in the given expression is 20x, we have to see, we can, if it is in the form 2 into 2x into 5, and indeed it is. So we see that this part is in the form a square plus b square plus twice ab, and hence it will be a plus b whole square, that is 2x plus 5 square. So this is the final factorization of the given expression, and hence the result is, the correct choice is C. C is the correct choice. Okay, let's do problem number 13. The given expression is 10p square plus 11p plus 3. First of all, we do not see any common factor in all the terms. Second, we do not see the form a square plus b square plus twice ab or a square plus b square minus twice ab. Okay, it is not having any form a square minus b square. And it is finally we see it is a quadratic trinomial. It is a quadratic trinomial of the form px square plus qx plus r. So we have to find a and b such that the constants a and b, two constants a and b, such that a plus b will be equal to the coefficient of p, that is 11. A multiplied by b will be equal to the product of the constant term, that is 3, multiplied by the coefficient of p square, that is 10, which is equal to 30. Okay, so ab is equal to 30 and a plus b has to be equal to 11. Then we can find a and b. What can a and b be? 30 can be considered as 6 into 5. Now, finding out a and b, you must be very quick. You must not take too much time in finding out a and b, if at all it can be found. So we can consider 30 as 6 multiplied by 5. So their sum is 11, and hence and also their product is 30. So you can consider 6 as a and 5 as b, even though it does not matter. So the given expression can now be written as 10p square, and 11 coefficient of p, you will write it as a plus b, whatever the values of a and b you have found. That is, in this problem, 6 plus 5 p, and we have p plus 3. Now if you further simplify, we get 10p square plus 6p plus 5p plus 3. Then you form two groups. The first group will be the first two terms, and the second group will be the last two terms. And I can say that I can see from the first group I can have 2p as a common factor. So I have 2p multiplied by 5p plus 3, and the second group is itself 5p plus 3. Now I can see 5p plus 3 can be expressed as we can always multiply by 1. So now we can see a common factor of 5p plus 3 in both the groups, and hence the final factorization will be 5p plus 3 multiplied by 2p plus 1. 2p plus 1. So the correct choice should be 5p plus 3 and 2p plus 1. So B is the correct choice. Let's do question number 14. Question number 14 is a relatively small expression, but it is not, even though it is small, it is not that simple. So 8x cube minus 2x. First of all, you can see, take out any common factor. If it is available, take out common factor from all the terms of the given expression. We can clearly see that 2x is the common factor from both the terms in this given expression. So it becomes 2x multiplied by 4x square minus 1. Now you will check whether we can factorize 4x square minus 1, and we can clearly see we can, because it is of the form a square minus b square, because 4x square can be expressed as square of 2x and 1 as 1 square. Now if we apply the identity of a square minus b square, we get 2x minus 1 multiplied by 2x plus 1. So the correct choice will be C. C is the correct choice. Okay. Question number 15 is a solving problem. It is a linear equation. The equation given is okay. The equation given is x plus 5 by 2 plus x minus 5 by 3 is equal to 25 by 6. Now you can see that in this equation there are all the terms are rational. All the terms are rational, having denominators 2, 3 and 6. So we have to find first the LCM of all the denominators, that is LCM of 2, 3 and 6, which is equal to 6. The LCM of 2, 3 and 6, 2, 3 and 6 is 6, and then we will multiply both the LHS and RHS by the LCM, that is 6. So we multiply both the LHS is x plus 5 by 2 plus x minus 5 by 3, and RHS is 25 by 6. So we multiply RHS by with 6. Okay. Now if you further simplify, if you do the products on both the LHS and RHS, you get 6 multiplied by x plus 5 by 2 plus 6 multiplied by x minus 5 by 3 is equal to, the right hand side 6 cancels out and we get 25. Now if you further simplify the LHS, you get 3 multiplied by x plus 5 plus 2 multiplied by x minus 5 is equal to 25. Now After further simplifying, doing the product of the monomials and the binomials on the LHS, we get 3x plus 15 plus 2x minus 10 is equal to 25. This implies we have 5x equals to 25 minus 15 plus 10, which is equal to 20. This implies x is equal to 20 by 5, which is equal to 4. So the value of x, or the solution or root of the given equation, is 4, and hence the correct choice is B. B is the correct choice. Okay, let's do section C, which are fill in the blanks problems. 16. This is problem number 16. Part 1. Okay, so this is all. Also again, we have to factorize x square minus 18x plus 81. So first of all, you will see if there is any common term in all the there is any common factor in all the terms. We don't see any common factor. Next, we will see if we can form a square plus b square minus a square plus b square plus twice ab, or a square plus b square minus twice ab. We can see that the given expression, we have x square, 81 can be expressed as 9 square. We already have found, we already got a square plus b square. Now we see, we will check whether we can find whether we can express the minus 18x as 2 into ab. So we must have minus 2 into x into 9, and indeed we get minus 18x. So this is, so we got the form of a square plus b square minus twice ab, and hence which is equal to, as per identity, a minus b whole square. So the given expression, the factorized form is x minus 3 whole square. Part 2, 4 minus 36 x square. First we will see whether we see any common factor in all the terms of the given expression, and we can clearly see 4 as a common factor. So we will factor that out, and we get 4 multiplied by 1 minus 9 x square. Now we have to see whether we can further factorize 1 minus 9 x square, which we can, because we know that 1 minus 9 x square can be written in the form of a square minus b square, that is 1 square minus square of 3x, that is 1 square minus 3x square. Now this can further be factorized using the identity a square minus b square is equal to a minus b into a plus b. So the final factorization becomes 4 into 1 minus 3x multiplied by 1 plus 3x. Okay. Part 3. We have to factorize x square minus 14x plus 13. Notice that we are not having of the form a square plus b square plus twice ab, or a square plus b square minus twice ab, because x square is fine, but 13, the constant term 13, is not a perfect square. So we cannot have a square plus b square minus twice ab form. Also, there is no common factor in all the terms of the given expression. What else can we do? We see that it is of the form, it is a quadratic trinomial of the form x square plus px plus r, x square plus px plus r. Now for this kind of quadratic trinomial, if you want to factorize it, you have to find values a and b such that a plus b should be equal to the coefficient of x, which in this problem is minus 14, and a multiplied by b must be equal to the constant term multiplied the constant term, that is 13. Since the coefficient of x square is 1, Now, if we can find values of a and b such that a plus b is equal to minus 14 and ab equals to 13, then we can directly say that the factorized form of the given expression will be x plus a multiplied by x plus b, because it is of the form, the given expression is of the form x square plus px plus r. Okay. Now, can we find a and b such that a plus b is equal to minus 14 and ab equals to 13? Of course, we can, because 13 can be considered as minus 13 multiplied by minus 1. So, minus 13 and minus 1 can be considered as a and b, as their sum is minus 14 and the product is 13. So, clearly now we can directly say that the factorized form will be x minus 13 multiplied by x minus 1. We can directly say that the factorized form will be x plus a into x plus b, because it is of the form x square plus px plus r, that is the coefficient of x square is 1. Okay, let's do part 4, which is 9z square minus x square minus 4y square plus 4xy. Now, this is a little complex polynomial having 3 variables x, y, z. But first you have to see, if you see any square terms, you have to first see whether you can form, you are getting the form a square plus b square plus twice ab or a square plus b square minus twice ab. Now, this I can clearly see that I can write it. So, we are having minus x square minus 4y square and plus 4xy. It can be expressed as the form a square plus b square minus twice ab, because we can write it as 9z square. If you take negative common from all the terms, from all the last three terms, we get x square plus 4y square minus 4xy. Okay. So, this is equal to 9z square. Now, x square is fine. 4y square can be written as square of 2y, that is 2y square, and we see 2x multiplied by 2y. So, this whole part is of the form a square plus b square minus twice ab. So, we can write that as x minus whole square of x minus 2y. Now, again we see that the entire expression, given expression has been expressed in the form a square minus b square, because 9z square is square of 3z and we have square of x minus 2y. So, this is of the form a square minus b square, and hence the final factor, applying the identity of a square minus b square as a minus b into a plus b, the final factorization becomes 3z plus x minus 2y multiplied by 3z minus x plus 2y. So, this is the final factorization of the given expression. Okay, let's do the last part. It is ABC minus AB plus minus C plus 1. Clearly, we do not see any common factor in all the terms. Clearly, we do not see any a square or b square terms. There is no square terms. So, the only thing we can think of, the only method or the rule we can think of in doing the factorization is forming groups. And as you can see, if you consider this as the first group and this as the second group, from the first group I can see a common factor of AB. So, I will factor that out and I am left with AB into, it will be C minus 1, and this group, that is minus c plus 1, I can consider it as, I can take negative 1 as a factor, and I can say rewrite the group minus c plus 1 as negative of c minus 1. Now I see that c minus 1 is a common factor in both the groups, and hence the final factorization will be c minus 1 multiplied by ab minus 1. I don't know how long this video will be or how much time I have spent in solving this test paper, as I had to write very slow. I'm really sorry for this. It was a very bad experience, but anyway, I hope solving this test paper 8 will be helpful to you in understanding how I am approaching to solve a problem, how I am applying the concepts of the two chapters, linear equations and operations on algebraic expressions, to solve the problem. It will give you a clear idea of how to solve the problems from these two chapters. So if this video was beneficial, please like it, share it with your friends, and also please once again support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So with this test paper, it brings to an end in the theoretical videos of the chapter of linear equations. Now I will start preparing and solving 10 good problems in the other playlist, that is Maths 8 Hot. So please keep an eye in that playlist for solving a little harder problems. So thanks for watching, and until the next video, take care and bye.